What's up, all you 7th grade cats and kittens? I figured I'd try that out. It's pretty topical for right now. It's me, Mr. Gerber, back at it again. This is our 7th week of Google Classroom. We're coming to a close. School's almost done. We can all see the end in sight. Yay. Okay? But we still have a little bit more work to do, and that's okay. Because we're going to go a little bit more into geometry this week. And this week we're talking about area and circumference of circles. So, without further ado, let's get right to the notes. About area and circumference of a circle, we need to know some vocabulary going forward. So, a circle will have a radius. The radius is the distance from the center of the circle all the way to the outer ring. And I can tell you that the radius is half of the diameter. A circle will also have a diameter, which goes straight across the circle from one end through the other, exactly through the center. Okay? And I can tell you that the diameter is 2 times the radius. So if you were to come across a problem and it gives you a radius of 5 for that circle, that means that the diameter of that circle is 10. And the same thing works in the other direction. If you're given a circle that has a diameter of 8, that means that radius is half of the diameter. So that means your radius would be 4 in that situation. We all have a pretty good idea of what area is, so I'm going to jump into what circumference means. The circumference is the distance once around the circle. Okay? It's how far something has to travel all the way around the circle one time. So, how do I go about finding area? Area is pi times radius, or it's pi times the radius squared. Many times you'll see A equals pi r squared, where r is your radius. This second power right here really just means multiplied by itself twice. So 2 times, which is also why they have times radius right up here. Okay, so let's look at a couple examples. In this example, they show us a circle and they show us that we have a radius because it's from the center to the outside, and our radius is 7 centimeters. So in this case, pi r squared, I have pi times my radius squared. So this is the same thing as pi times 7, or pi times 49, which comes out to be, this is supposed to be a decimal, not times, 153.94 centimeters squared. Okay, let's try another one. In this situation, I'm given a diameter because it's from one end of the circle to the other through the center, and they're telling me that the diameter, or d, is 10, which means that my radius, or r, which is half of my diameter, has to be 5. So this is pi times 5 squared, or 25 pi. Oops. And once I actually put that into the calculator, that comes out to be roughly 78.54 centimeters squared. Not too bad, right? Let's try this with circumference now. Circumference is actually a little bit easier, okay? Circumference is really just pi times whatever your diameter is, okay? Or it's 2 times pi times your radius. Straightforward. Let's do some more examples. In this situation, they gave me my diameter because it's from one side of the circle to the other through the center, and it's 4 centimeters. So it's really going to be 4 times pi, which comes out to be not 12 times, but 12.57 centimeters. Notice how this time it's not centimeters squared because it's still one dimensional. Okay, it's that one line dimension going around the circle. Okay, let's try one last example. In this example, we are given a radius because it goes from the center to the outside. So if my radius is 8, that means my diameter is double that, which is 16. So all I have to do is pi times 16, and I get 50.27 centimeters. And I also could have done this by doing 2 times pi times 8, and I still would have gotten